Okay, I threw a couple more in there just for, you might see these kind of, especially dodecagons, for some reason in science. I feel like you guys talk about them in science. So I wanted to throw those in there too, but I'm not going to make a big deal of these. Usually any more than 10, they're just going to call it a gon. So if it has 20 sides, it's a 20agon. Things like that. So they'll just put the number with it. So just make sure you know 3 to 10 for your vocab. Classifying them, if you see, and you definitely see this stuff in science class, convex and concave. So convex, that just means all the angles are pointing out. So these are our normal pictures that you see like these. All your angles are pointing outwards. This is the fancy way to say it. If no line contains a side that passes through the interior, it's a really weird way to explain it, but they're just saying if you basically draw a straight line through it, it's not going to go through the inside. So if you continue to draw all of your side lengths, none of these lines that I'm drawing are going to go through the inside. That's what they're talking about. Basically, it's just every corner points out. As for concave, I like to think of it as something caves in. That's how I remember the difference. Convex goes out and concave caves in. So in other words, see how these angles right here, these are all pointing inwards. They are caving in. So those 5 cave in, these 5 at the end of the star point out. So it has 10 different angles. And anytime you have at least one cave in, as long as you just have one, it's concave. Okay, so this one only has 2, here and here. So that makes it concave. Even if there's one, it's concave. All the rest of them are convex. All the rest of them point outwards, but you have 2 that point in. Now, what they're talking about here, any line that contains a side that passes through the interior. In other words, if I were to draw this side of the star, it goes through the inside of the picture. Same thing over here. If I do this side, it's not going. But if I do this side, it's going to go inside and it's going to go in the interior of the picture. So that's what the formal definition means. That doesn't really make sense unless you get the example with it. Okay, but just think of it as if you've got an angle that's pointing inwards, it's caving in. So that's concave. Okay, we know equilateral. That means all sides equal. Usually we do triangles, all equal sides. It doesn't matter. It can be a quadrilateral. It can be a star. It can be any picture. As long as all the sides are equal, that will make it equilateral. Equiangular is going to be equal angles. So that star up there was equilateral, but it wasn't equiangular. But down here, all equal angles, that means equiangular. Now, a very important word you're going to see a lot of is regular, and that's when it's both. So if you have equal sides and equal angles, so equilateral and equiangular. So like the triangles, we know they had all equal sides, and therefore we have all equal angles. And that works for all of these. I just gave you an example of all of them. So if you see the word regular, that's an important one. That just means all equal sides and all equal angles. So when we start doing this, when we're talking the sum of the measures of the interior angles, interior means inside. So we're talking about all of these angles and what they add up to. You will see this a little bit in the IXL, where it wants you to draw a diagonal from the vertex. So here's my vertex they highlighted. My only diagonal here is this one, okay? Now, if you do them from here, it's just connecting this dot to all other vertices. It's already connected to this one and this one, so I don't have to do those. So 2 diagonals with that one. This one, connect to all my corners. This one has 3, and this one over here, if I connect to all my corners, this one has 5. Okay, now the point of this is to explain how to get the interior angles, because usually when we do a triangle, the sum of the interior angles of a triangle, everybody knows is 180 degrees. So the 3 angles add up to 180. Well, if you look at a quadrilateral, we know it's 360 because that's what I told you before. The reason why is if you make it into triangles, it has 2 triangles. So these 3 triangles add up to 180. And these 3 angles in this triangle add up to 180. So total, if I add all 4 angles, you're going to add those and get 360. Same thing here. I've got 3 triangles. So it's 180, 180, and 180. So this, I'm going to have to add them 3 times and get 540. So the sum of the 5 angles is going to equal 540 for this one. This one's 360, 540. This one has 4 triangles. So if I have 4 triangles, 180 times 4 I think is 720. And then this one has 1, 2, 3, 4, 5, 6 triangles. So that's going to be 6 times 180, which is 1,080 degrees. So this one has 1, 2, 3, 4, 5, 6, 7, 8 sides. So notice if I have 8 sides, I have 1, 2, 3, 4, 5, 6 triangles. This one I have 6 sides, and I have 4 triangles. I've got 5 sides, oops, and that means I've got 3 triangles. This one I've got 4 sides, 2 triangles. So if you notice, 4 to 2, 5 to 3, 6 to 4, 8 to 6, there's always 2 less triangles than however many sides you have. So this is where this formula down here comes from. So you're going to use this formula to find out the interior angles. So you just take 180, you take the sides, the number of sides, which is n, minus 2, because it's always 2 less triangles than the number of sides. So you subtract 2 from the sides and then times it by 180, because that's how many triangles you're going to have. Okay, so that's really important. Interior angle sum theorem, that's going to give you the inside angles. So take the number of sides minus 2 times 180. All right, a couple examples. Now from the rest of here, that was all the info. I know it was a lot of info, blah. Now I got to start doing some problems with it. So they're asking you for x. So what you need to do is count the number of sides. Here's a hint. If you have trouble counting the sides, just count the angles, because the number of sides and the number of angles is the same. So if I count 1, 2, 3, 4, 5, I got 6 sides. So if I do 6 minus 2 times 180, 4 times 180 is 720. So I know that all of these add up to 720. So now all I got to do is add them. X, 90, 124, 150, 93, and 130. So I added all the angles, set them equal to 720. Okay, so all you really need to do is take that 720 degree angle and subtract all those. So I'm going to subtract 90, 124, 150, 93, and 130. So if I subtract them all, I'm going to get 133 for my x. Okay, so these are types that you'll see. Over here, they give you a bunch. So they give you a whole bunch more x's over in the next one. So in that case, I've got 1, 2, 3, 4, 5 sides. So if I do 5 minus 2 times 180, that's going to give me 540. So now I know that those 5 equal 540. So I need to add them up. So I've got 4x and 10. I've got the 7x, 4x and 5. I've got 5x minus 5. And I ran out of room. I've got 6x and 10. There we go. Okay, so if I add my x's, 4, 7, 4, 15, and 11 is 26 x's. And then I can just add my numbers. So I got 10, 10, 5, 5 minus 5 is nothing, and then 10 is 20. Okay, so if I subtract 20, that's going to give me 520. And then I'm going to do 520 divided by 26. And that's going to give me x is equal to 20. And that's all they asked you for. They just asked you to find x. Okay, so it can be complicated where they give you a bunch of x's. Just set up your formula. The most important thing and the new thing is you're finding out what all the angles add up to. So you just take the number of sides and then subtract 2 times 180. So just, you can count the angles if you want instead of the sides. All right, these are different types of problems. You're going to see them all in the IXL. So it says, what is the sum of the angle measures of a 14-agon? So if I do 14 minus 2 times 180, that's all I got to do. So when you see the word sum, this is all they want. They just want the total. So if I do 12 times 180, it's going to give me 2,160. So if you see the word sum, this is all you got to do. So this one says each angle, which means you need to find one. And if it tells you it's regular, that means everything is equal. So pentagon's 5 sides. I got to start here. So 3 times 180 is going to give me 720. That's the sum of all of them. I need to find each angle. And since they tell me that they are all equal, that means I just divide it by 5. So that's going to give me, so that's going to give me 144 degrees for that one. Okay, so if they're all equal, you just got to figure out what each one equals by dividing by the number of sides. Okay. This one, they asked for the measure of angle C. That was just attached. We did one like this already. So I've got 1, 2, 3, 4, 5 sides, which I just found out that adds up to 720. And then I can just subtract 90, 105, 86, and 137. Just subtract them all. That's going to give me that. Okay, finally, in a regular polygon, again, this means they're all equal. The measure of one interior angle. So when you see that word and, that's just one interior angle, is this. So they want to know how many sides does the polygon have? Well, we have no idea because usually we do this. And then to find out what one angle is, what you would normally do, what we were doing up here, was we divided by the number of sides. So we did this n minus 2 times 180, and then we divided it by that same n, by that 5. So here's what we're doing. We're doing n minus 2 times 180. I don't know the number of sides. And normally I would divide it by the number of sides. This is what you would basically do to find one angle of a regular polygon. They told me that the answer to this is 156. So this is the way to ask when they give you an angle. You've got to set up a formula. So now I need to solve for n. So what I would do next is times by n. That always gets rid of a denominator like this. Okay, next thing I'm going to do is I'm going to distribute that 180. Okay, so that way, I mean, you could do a few different ways, but that's probably going to be your best way to solve this. So I'm going to get 180n minus 360. That's what I get when I distribute. Then I'm going to subtract my 180n from both sides. Wow. Okay, let's try that again. So I have the negative 360. And 156 minus 180 is going to give you a negative 24. Okay, and then your last step is to get n alone. You'll never get a negative number of sides, by the way. If you do, you did something wrong. Negative sides don't make any sense. So I've got 360 divided by 24, and that's going to give me 15 sides. So 15 sides for this one.